For every person that learns SwiftUI, there comes a time where your code becomes increasingly more difficult to read and to debug and to work with. And that's the moment when you decide to learn something about architecture. And the thing that you come across the most is MVVM. So what's the deal with MVVM and how does it fit in with SwiftUI? So we have MVVM, so you have views. And most of the time, you start to explore the different views and components. So for example, we have here, all the blue stuff is the views. We have here container views like stacks and lists. We have view modifiers like borders and button styles. We have shapes. We look at animation and user interactions like text fields and buttons and gestures and drag and drop. Although drag and drop is maybe not the nicest thing in SwiftUI yet. At the point where you look at more advanced features, you start thinking about the data flow. So you will see stuff like state, binding, ObservableObject, state object, environment object. And I guess most people get a little bit confused on what all this does and when to use which one. You might hear something like combine. You start to appreciate this, observable objects, when you look more into view models. But definitely you want to go for MVVM as soon as you consider data persistence. Where does your data live? How do you want to store it? Where do you get it from? So you have network calls, you look at the file system, you have a document-based app where you store your stuff in the file system. You might use Core Data, CloudKit, Realm, or Firebase. So where do you put this kind of code? In order to make this more concrete, we're going to just create a little messy example where we are doing it the wrong way first. Then we have again a look at MVVM. And the last thing is we're going to rework our code to use MVVM and see some of the advantages. So let's create a new project. I'm here creating a project for iOS. It doesn't really matter because we are just having a look at our code organization. This is a single view app, or as they now have it, just app. In this project, I just want to test some of the features we get with lists. So I'm naming this list test project. I'm not here including core data or any tests yet. And because I'm highly motivated, I'm going to use the new SwiftUI lifecycle since we only want to test some features. It's nice to always see the new stuff. So I press next and I save this. I only have here a couple of files. And the first one is the application main file. So this is because I choose SwiftUI lifecycle. So we have here our window group and the one view that it's referring to is a content view. And in the content view, it per default just creates us hello world. So in here, I'm going to place my list code that I want to see how it works. And now search for a tutorial on lists and in particular on delete. So I'm just going to recreate here this tutorial. So first, they're having everything in one file. First, they define a item struct. So this is a struct item, and it has two properties, a var which is ID of type UUID, and a var which is name, which is a string. So basically we only need to have a name for this item, but we choose to have the ID. The reason is so we can have identifiable, so we can use it in the for each. So now in our content view, I create here a var items, which is an array of items, and I'm just going to create a couple of items in this. So I start with a UUID. For the sake of this test, because I just want to test it, I'm giving here to a dummy name. So I have my first item, then I have another item with another ID it creates for me, and this is my second. And then I have another item here, which is a UUID and I'm naming this here third. In my body now I have something to show, so I show here a list. What I care about is the on delete, and this only works on a for each, so I need to use a for each in my list from data. So in here I have my items. Since they are identifiable, I don't need to use this ID because already the system knows how to identify them. So then for each item, I'm here displaying my item's name. And now I should be able to see something in the preview. And I'm going to change my schema here to an iPhone 11. Now this is looking good. I have something that I can see in my list, in my preview, and I can finally use the onDelete perform, so I get an index set back. And I know that for each index in my index set, I'm going to delete this item. I'm going to remove at this index. So every time this delete function is called, I'm just going to remove the item at this index. And now it gives me this error. Self is immutable. cannot use mutating member in immuting value self is immutable. And this is the first time I start to see the automatic update of SwiftUI. And the reason is, this is a nice hint for us because it means that the system wants us actually to change things, but it also wants to make sure that it displays the new updated things. And if I just have a var items, the system doesn't know how to update it. So one of the things that help us to fix this is if I make this now a state property, because this property wrappers, the add side is property wrappers, and property wrappers add functionality to any of our properties like our items. And in this case, it adds a automatically updating the UI if this state property changes. So now this is fixed and I can try again, and I can even use here the live preview and use my swipe on delete, and you see I did delete the right ones. I'm like, okay, this is nice. So now I'm highly motivated and I want to add more things and see how fast I can create a full list here. So I stop the preview. So one thing I would like to also have in this list is a on move. So here we're going to add a on move perform. So this is index 2, and I can use a items dot move from indices to new offset. What I give you here in this closure is exactly the two values that make it easy to work with arrays. So it's quite nice. If you want to see this in the preview, I cannot. In order to move things, you need to go in edit mode. So I would need to add here an edit button. And since I like to have the edit button in my navigation bar item, so on the top right corner, I'm like, yeah, why not add a navigation view? And I'm going to close this after my list. Then we're going to add a navigation bar title. Whenever you start learning a new programming language, at some point, sooner or later, you will create a to-do list, and this might be our to-do list. And this has to be a text, not a string. And here I even have this display mode, so I can decide how to show this, so I can have large or inline. If you don't want to have it so big, but I guess large is fine. Then I want to add here an item in my navigation bar, and navigation bar items is decorating with iOS 14, so we can use now the new one, which is a toolbar content. So I would here add my edit button. So now I can run this in live preview again, and I can here toggle between edit buttons and move my items around. And since I'm already here, I want to add a new item every time. So in order to use multiple items in my toolbar, I need to use a toolbar group, toolbar item group with placement. So, and the placement I'm going to use here navigation bar trailing. So now it's going to be there. And I add here a plus button to add a new item. So this is a button from action. And I'm not using a text, I'm using a system icon. So image. And then I definitely have to create a new item, so I can in this action call say items.append new element, and I'm creating here an item with a new UUID, and the name is newly added. And since I have a navigation view, I can also use here navigation links to investigate in all of the new features of navigation views. Navigation link with destination and label. So the label stays the same as the text I'm using here, and the destination, just using a text, and I'm displaying in my text here destination item dot name. Now I get this nice hints, these arrows on the right side of each cell. So I can go to my detail view, I can go back, I can add new items, I can edit things, but we are running into a couple of problems here because all my code is in one file. And this is usually what happens when you see tutorials, because they try to make it as short as possible and they don't want to distribute so much, so you see it at once, which is probably good, but give you the wrong impression. What I cannot do is I would want to have here different views, so you can add new simulators in the canvas by adding this plus button. So I have here another preview, and maybe in one preview I want to see the empty state, so I don't want to see any to-dos in there, any items, but I want to have a placeholder, so I want to work in the preview to see the state. How do I change it? I defined all my data in my view, and all my business logic is in the view. My model is even. Everything is together. And I need to decouple my view and my model. I also want to test, for example, this move and this delete functions here. And I have a view. I want to write unit tests with views? Not really. So now it's definitely time to look at how MVVM works. So I have here this little drawing Right now we had everything together in a view. So the view, this is where we declare what UI we want to see. In our case, we have a declarative programming with SwiftUI, but our views need to display some data. In our case, it's the to-do list items. So it needs to pull this data from somewhere, and it needs to get this from the view model. Right now, we had a direct connection to our model. It directly connected it to the model, but we should not do that with MVVM. So the view pulls this data, and it also should react to changes in the data to always show the new ones and read all this view, so we have an automatically update and we always see the right data. So there's no mismatch between the underlying data and what the view shows. We always want to see the truth. The other thing that the view wants to do, you have user interactions and the user wants to see different things, or he wants to change something. For example, in our list, we would want to say, okay, I ticking one of our to-do list items to say, oh, it's done. So there is some user intents where we would need to change the underlying data. And the views shouldn't change the data directly. They should call functions in the view model which process the intent. So the view model should be responsible for modifying the model. The model, which has the data and the logic, does not care about the view model. So it's just blind to this side, but you need to have a way of letting the view model know that something changed in our data model, because the view model internally needs to also communicate to the views that something changed, re-render the views, draw something. And the view model is basically the interpreter between the model and the view. So it's the in-between instance. And the view model only has that's why I have this little faces here. The view model sees the model, but it has a blind eye towards the view, so it doesn't really know about a view. It doesn't care where it's used. It's just like, here's the data. Whoever cares can take it. So you have a blind structured communication towards the views. The view itself sees the view model because it needs to pull the data and needs to ask somebody, I need to show this and this, and let me know when something changed so I can re-render. In order to make this work, we have this binding, this blind communication and this data flow of updating the views automatically when the data changes. It's hard to do this with UIKit because this functional programming is always called and where you have to tell it specifically redraw. With SwiftUI, we don't need to do this because we have some tools to do this. And what I also want to show here is you see this kind of circular way. You see this kind of circle of data flow where you see that the view doesn't talk directly to the model. If the user presses a button, the view model handles the process, changes the data. The underlying data is changed and we see that our view model publishes that something's changed. And the views receive this new published information and redraw themselves. So you would never in SwiftUI say redraw. So I have here again these three parts, the model, the view model, and the view. So from our model part in Swift, you usually use structs because structs are value types and this helps the view model to easily know if something changed. But how does the view model communicate something changed? How does it publish something changed to the world? And you see every view model in SwiftUI should conform to ObservableObject. And when you do this, when you conform to this protocol, you get a object will change pass through subject. So this is the one radio station, or this is the one communicator, one blind communicator to the world, to the outside world, to our views. And in order to create something changed, a notification, we can call on this object will change a .send. When is this called? Because usually you don't see it anymore. That's why we have this for each property that we use. In our view models, we usually add this @ publish to them. And this property wrapper creates publishers for each of our properties. It also starts a data flow that whenever this property changes, this object will change .send is fired. So we have now our blind communication to the world, but how does the view pull this data? And in order to get this data flow going, we have here three different possibilities of property wrappers again. So we have an environment object, an observable object, and a state object. I will talk a little bit later when to use which one. So the view knows about this view model. So that's why I have here this small red boxes. It has a window, an access point to the view model. What the view could do, it could show a property in the view model, like you have a user and you want to show the user's name. In this case, it's a one-way directional data pull. You just go from the view model and want to show it in the view. But what happens if this property needs to be changeable in the view? For example, you have a toggle. So the toggle has a Boolean value and you want to give the toggle this value, and inside of the subview of this view, it needs to be also changeable. So we have a special way of passing these values further down, and in order to do this, we use this kind of binding, so this @ sign, which allows the toggle to pull the data from the view model and also update it. So you always see the same value in the view and in the view model. Because we have publisher in our view models, you can also subscribe to any changes in this for these properties with this on receive. And this is probably the least likely thing to do, but it's a good example of how this data flow goes. If you subscribe to a publisher, you have a myclass.$myvar. So this is a subscription to a publisher. And in this closure here, this is called whenever this value changes. So you can do whatever. You can start an animation, update another thing in your views. And the binding is a binding to this class, to this view model, because the view model object will change to handle this. So you have to just be a bit careful where you place your $sign. And then the last thing that might happen in your views from the user's perspective is just an action. Something happened. The view doesn't need to do anything here. It just needs to upwards again communicate something happened. So we have here an action closure where we can do whatever we want to. And since it's probably something related to our data, this view shouldn't take care of this. Our view model should do it. And in order to process this kind of user intents, we use function calls in our view model. And these functions then internally in the view model can change our structure or data model. So you see again this kind of circular data flow or interaction data flow style. I already said the word state and truth and declarative. One problem that you have to solve is that you always have to sync the data and the updates to the data with what you are showing on your display, on your views. So there should be only one truth. If your views show something different than your underlying data, then there's two truths, and this is not good for the user because then you have some wonky behavior. What do I mean with the truth? What can be part of your truth? So obviously I already said the data. In our example, it's the user's to-do lists, all the items in your list that you want to display this kind of information. Another truth that can be out there is the user state. So is the user logged in? What kind of user account does he have? Does he have a pro account? Because if you have a pro account, in some sub-views in your application, you might want to unlock certain features. So in there, you would always say, okay, disable this button if the user is in pro account. So this is a very different kind of state. But you would need to handle this login state differently than pulling the data. It's a good idea to separate them in two different view models. Another example of state is navigation. So this is one of the things I guess most people are not aware of when they start with SwiftUI, because you don't really see it. For example, in our list, in our navigation stack, we have a navigation state of, is it my main view, my list of items, or do I show the detail view? And in the detail view, it's actually different state because I can show different items there. I can have also navigation states showing alert. That's also a state. I could show a popover. If the user first time launches, I would show the onboarding. So I would have the onboarding stage. Maybe in the onboarding, I have a login request. So the state would be show login view. And this kind of state is a state that defines the whole application or the whole window scene, because for the iPad, you can have split screens and have two different navigation states for each of these views. Or if you're on macOS, you have multiple windows and maybe you're in different stages in these windows. It can be a scene state or an application state. And then the last example is maybe I have a API integration. For example, I want to play sound with AV Foundation. So I would need to create a music player. Would I put this player in my view where I need to import the AV Foundation, where you need to create the player, set the sound, start the player, finish, repeat the player? Would I put this in the view? Or is it not better to separate it and create a view model for this? And the view model I can reuse on multiple occasions, so I can have a nice ping sound whenever the user taps on finish the to-do list item. So we have this kind of different truths that we want to see. Do I play a sound? Do I show this and this alert? Do I show this and this data? Since we have different states, the user definitely goes through different stages of different states. And a nice thing to show the transition of the states to make it more pleasant for the user is to use animations. So how do you show changes of the truth of the state? This is with animations. And the reason why animations work so nicely with SwiftUI is because it's declarative. You have this state and this state, and the only thing that you need to tell the system is animated or not. And how do you animate this? With which properties do I want to animate? So we have now the truth. And the question is, since it's only one truth, who should be the owner? Where should I place my truth? Who should have access to my truth? So we're going to have a look at different people instances that can have the truth. So can a view be the owner of the truth? Can the scene be the owner? Can the application be the owner of the truth? How do I share the truth? So we start by the lowest level. Can the view be the owner of the truth? So for example, I have here another little view. And for example, I would want to allow the user to mark this to-do list item as a favorite. But I don't want to do it directly, so I want to have an intermediate state, and only this property, this intermediate, is it favorite or not, is in this view. This view can be the owner of this property, and you see here, we do this with this add_state property wrapper. This add_state property wrapper we use for single values of simple types, like here a boolean. And then the question is, how actually does the toggle use it? Because the toggle needs to have access to this is_on property here. It needs to read it in order to show the right state if it's on or off, or it's true or false. But it also needs to change it. Whenever you want to have a read-write access of a subview of this property, we use @binding. And the other case is if the subview wants to read this property, if it just wants to know about the property to display it properly. For example, in this text. This text doesn't need to change it, so it doesn't need to have a binding here. For the subview, it's a simple let property. So what happens if in my parent view this property would here change, which I didn't show here correctly. If you change it in this view, this text is redrawn. So you would just recreate this subview. This add_state property wrapper is again a data flow, a publisher stream. And you can see this because they now added for SwiftUI 2 a new view modifier which is on change. So any view can subscribe to changes of state properties now. In this case, I'm here subscribing here $is_on to changes of this is_on, which means that here this view says, okay, whenever this changes, I want to be notified. I want to know about it and I want to react to it. So we have here in this closure, we get the value and we can do something with it. Okay, so this is the example of having a view being the owner of a property and also transferring the same property downwards to its subviews. What happens if my view wants to access a view model? So the view model can declare itself as the owner of a view model. And in this case, we use a different property wrapper, which is add_state_object. So this is very similar to add_state. Just in this case, we have an object. So what you declare here, our state manager needs to conform to ObservableObject, hence the name state_object, in order to let this declared. When the view is first time created, this state manager instant is created. So this view can be the owner of this state manager. How can it hand down information of this manager to its subviews? So similar to what we just saw with add_state and add_binding, we have now a add_state object and our subview has a observed object. So you see the subview doesn't create an instance of the state manager because whenever you call this view, in the initializer of this view, you have to give it an instance of this manager. We are directly handing down an instance of this manager to our subviews. But we also have another place to be, and that's the environment. So this is a more general place to be. And in order to place it there, we can use a view modifier .environmentObject. And this view has now this object accessible and all of its subviews. So it has a window in there. The environment is even more interesting when we have a look at the whole application or the whole window. Since we have two different ways of creating applications, one with the app delegate and one with the window group. Let's go through them one by one. So let's say you have one truth that you want to share through all of your application. Like in our example, to-do list, all the items should be the same wherever. We can tell our scene delegate to create this view model. And now we have again these two possibilities. So we can either give it to the subviews as an observed object, or we can use the environment. But since I said I want to share it for all of my application and also in some of my subviews, so I have here each of these gray boxes is one view, and then you have this view that directly wants to talk to it, the subview doesn't. This view, it has another subview, it has another subview, and another subview, and down there I also again want to use my view model. If I use my observable object, I would directly need to always handle it down and call it every time I call one of my subviews, even though I don't always use it, which is a bit repetitive. So if you are sure that all of these views and its subviews use the same object, you can use the environment. So for example, I can now on this topmost view add this object with .environmentObject, and then in my subviews I can access it with this @environmentObject. You might not ask, okay, how does the subview now know which one to use? There can be only one instance of each type. So I can only have one state manager. When you access this @environmentObject var, you have to specify the type, and this is how SwiftUI knows which one to use for you. If you choose to create your application only in SwiftUI, so you have a application main and you have a window group. If you want to share this view model with all of your views and you only want to have one, you can make the application the owner of this view model by declaring it here with a state object. And then you can give it to all of your subviews again with this environment object. And if you do this in the window group, all of your windows, so if you're in the iPad and split screen, all of your windows will have the same state manager, the same truth. If you want to have different objects for your window scenes or for your windows, you can always create instances of these truths, of these view models further down in your hierarchy. So we have now a understanding of the data flow, that we have to separate our codes in view models and views. And we also saw where this observable object, this publisher streams, and this add state objects come in. So we can now use this for our little test demo. So if you have a look at the MVVM, we know that we need to separate our code into a model, and view code. So to emphasize this in my project, I create now 3 new groups. Model, a new group for my view models, and a new group for my views. You might want to have more informative names of your groups in your actual project. I just want to help us to distinguish between the different parts. So let's start by separating the model from the view, because this is definitely the one that I should get out of there. And what we had here is the item definition. So this is our model. So in our model folder, I create a new file, which is a Swift file. Most of the time you use here 2 different types, the Swift file, which is the model files and the view model files. So for this, you would always use a Swift file. And for our views, we would use the SwiftUI view. So since we are creating a model Swift file, this is a item because this is how I named it. And I'm going to move my item declaration into my item file. So this is now nicely separated. It's a basic model, but you might want to add here more business logic and different initializers, more functions or computed properties. Then we go back to our content view. And I want to now I want to get my data out of there. So I want to separate my model more from my view with this items array here. So definitely I should move this out and have a view model who should hold the information of the items. So in my view model group, I'm creating a new file, which is a Swift file. And I'm naming this my to-do list manager because it's managing my to-do list items. Or it's my state manager, if you prefer this word. So if you have a look at our view model, in order to make this work with SwiftUI, we need to have here a class. View models are usually classes, and I will have to mention this in a minute. And we need to conform to ObservableObject to start our publishing streams or data flow stream. And we should use for all the properties that we define there @published. So I have to here declare a class. This is my to-do list manager. This is an observable object, and I want to have properties, so @published var items. This is an array of items. I'm just going to, from my content view, use the same starting point we used before, so with the 3 items. So this is it. I just moved my data information in here. Right now I'm using here these default values, but at some point I need to load my data. And for this, we can use here initializers. So in the initializer of this to-do list manager, I would get my data, for example, from the file manager, and then set it to my items array. So let's now use this newly amazing view model in our content view. In my content view, I'm not using here this items array directly because I'm a good programmer. I want to here now use this view model. So when we have a look again at our little graphics, we had here 3 different ways of doing this. We had the environment, observed object, and state object. So the question is now, who should be the owner of my to-do list? And since it's list items, I want to make sure that it's everywhere the same in my whole application. So I probably want to make my application the owner. Since I'm using here the new SwiftUI lifecycle, in this example, we placed it in the environment. I could also handle it down to my views with this add observable object. So the question is, which one do I want to use? And right now I'm a little bit undecisive, and I guess maybe the environment is a little bit too much. So I will go through handling it directly down to my view with a observable object. So in my content view, I would not be the owner. I would take it from upstairs from the main application. So I would use here add observed object var, and this is my to-do manager, and this is a to-do list manager. So I'm not using these items directly anymore. So now here in my preview, it complains because it needs to have a missing argument. So I'm just going to create here new instances, and we have a look at the advantages of this for us in a minute. I want to set up the whole application first. Okay, so my content view is now getting a reference of the to-do manager for my main application. So my main application should create an instance of this class. So I use a add state object var to-do manager, and I'm creating here an instance of my to-do list manager. So my content view is now asking, I did not save it. In my window group, when I create my content view, the content view needs to have an instance of a to-do list manager, and I'm giving it here my to-do list manager from my application. And what you do here in this case, because my to-do list manager is a class, when you hand it down, you don't create copies. What you hand down is pointers to do this instance of this class. Like this, since I'm only handling around references or pointers to the same class, I make sure that all of them access the same instance, and I don't copy something and it's not different ones. And since this kind of view models are handled around so much usually, or it's more common to handle them around, and you want to handle them around and not create different ones, that's why these view models are usually classes. In Swift, these are reference types. So now we have created a to-do list manager. We have used this in our content view. One thing I really like to do is I don't really want to have this content view name. This is not very descriptive, so we're going to rename this. So you can command click on the name, rename. Now it looks for all the instances where it has to change it. So I'm going to change this to my to-do list view. And since this is a view, I'm moving this in my group folder. So now I have nicely separated 3 different classes. Now I have to make sure in my view that I don't access directly the data, but I ask my to-do manager for the data. So here I have my to-do list with this for each. So I'm asking my to-do manager for its items. Then you see here we have this on delete and on move. And in this case, we see that we actually change our data. This is what we definitely shouldn't do. We shouldn't change our data in our view. We're going to move this intents to our view model to process them there, and we're using functions. And the first one is complaining is the on move. So the directly processing of our data we shouldn't do in here. So I'm cutting out this items move. Instead, our to-do list manager should take care of this. So in my manager, I'm creating a function to handle this intent, which is a move. So I'm going to place here the code that I need. So I have here from indices to indices with new offset. Need to have them from my view. So I have here a indices, which is a index set, and the new offset I need is a int. So I comment save this, and in my to-do list I can now on move call my, whenever the on move is invoked, I can tell my to-do list manager to take care of this. So I call here move indices to new offset. So the next error it gives me here is when I create a new item. This is again that here my view manipulates my data directly, which I don't want. So I take this out, and we are going to create another intent function in our to-do list manager. So I'm calling this func add item. Right now I don't take any arguments because I only create here a dummy item. But you might want to give here in this function the name, so the string value. So I have this function and I can use it. When I tap on this plus button, I can ask my to-do manager to add a item. The next place where I directly access my data here in this view it's on delete. So I'm taking this out and we're creating another intent function in our to-do list manager, which is func delete. And in this case, we have to process the index set. This is the index set. We can place the code from our view now in here. So for all of the indices and these indexes, we're going to remove the items and this at this index. So now I have a way of processing this intent in my manager and in my to-do list view. On delete, I'm telling my to-do list manager to handle this intent and delete at this index. I now moved all of my direct data processing out of my view into my to-do list manager. Whenever this is called, for example, the delete, my to-do list manager deletes an item. So my array here changes. Thanks to this data flow of this observable object, my object will change.send is invoked, which in my to-do list view tells any of the views that use one of my properties for my manager that something changed. So this for each checks what is changed. So it compares before and after, and only if something actually changed, then it redraws itself. So we can run this example again. So I can add here items. I can go into edit mode and move my items. So now that we have separated our code nicely done, we're going to have a look at what advantages this is actually bringing us. So the first one that I want to talk about is in our preview. Right now, I have here two previews that show the same, but maybe in the second one, I want to show an empty state. So what happens first time the user launches the application and there's nothing in the list? I want to see something different. And I want to also be able to see this different state in the preview. I can here now create different instances of my to-do list manager. So in my to-do list manager, I'm going to create here static functions that create me some default managers instances. So a static function is called on the class, not on the instance of this class. Func empty state. And this function should return me a to-do list manager. So in here I have a manager. So I need to create a manager from a to-do list manager. In my manager, I can set my items to be empty because this is the empty state. And then I return this manager. Some things you might want to do is I'm here simply calling this initializer here because right now I don't do anything. But in some cases, you might want to load data from your file system. And in the preview, I don't want to do that. I just want to have an empty one. So I wouldn't want to go through all of these settings. So this is reflecting to dependency injection. One thing I can do this is in my initializer here, I can say is for tests. And this is a bool. Depending on if I want to have one for testing, I would create a different one. I don't want to always specify here is this input variable. I can use a default one, which is false. So in my initializer, if is for testing is true, then I would get my data from file system or I would connect to Firebase for login or whatever you need to do. But for my empty state in my preview, I don't want to do this. So in this case, I can call is for testing true. So don't do this stuff. So we have now a nice way of creating different instances or different states that we could be in. One was for the empty one. And I can create another one for my preview, for example, with full state. I'm again creating here the to-do list manager. I'm again creating an instance for testing. And in this case, I want to set the items here to some default values. And what I right now did, I used here these items. Which I'm going to move down here, and I can return this manager. So normally you wouldn't have any items in this array because that's what you do in the initializer when you load your information. So now I have these two nice static functions that I can use in the preview. I comment save. In my main application, when I create his to-do list manager here, this one would create one with loading the data. And in my to-do list view, in the preview, I want to see here now these two different states. So my first instance, I'm calling empty state. So you see this one is the empty one. And I can even, because later I might forget what I actually want to see, use here in the inspector a name which is empty state. So now you see here it added this preview. And then in my second, I would want to see here a full state. So you see in my second one, I have now some data, and I can use again here the inspector and give it a name, which is data exists. So now you see here this title, so it's easier for you later to work with this preview. And in this example, since I have nicely the preview for this empty state, I can decide what I want to show in the empty state. So how do I want to show when I don't have any items, so when my state is empty? And right now I only have here a list. I want to add a text saying, please add items. So you could use here a overlay or Z-stack. So I guess I'm going to use a Z-stack. So I want to show my empty state on top. Now in this Z-stack, if my to-do managers items dot count is 0, then I know I'm in the empty state. And I'm going to display here a text saying, please start by adding items. And to make it more clear this is the empty state, I'm going to change the foreground color to gray. And now I have two different states, one with the empty state, where I see this animation or drawing or just text, and I have the state where I see my list items. Another example where these view models come in handy is that I can now easier write unit tests, because I separate my business logic from my views. So in our case, we're going to create really tiny tests. So in my navigator test area, I'm here creating a new unit test target, because I didn't do that when I set up my project. So just stick with the name. We have a look. There's one test class here already in there. You can create new test classes here with new unit test class. So I'm just going to remove some of this code. In order to use the code for my project, I need to import this. So this is add testable import, and then the name of my project with it, my list test project. So now in this test example, I'm going to test something in my manager. So this is my to-do list manager. And now here is the question, which one do I want to use? And I'm going to go for the empty one. So I'm using the empty one because I only want to test the delete and the adding functionality. So when I create my manager, the first thing that should be true. So xct assert. So you see here, you can define if the condition that you say should be null or true. So I'm just going to put true with a message. What should be true? That my manager shouldn't have any items. So the items arrays count should be 0. And the message to my future self is should start with empty list of to-dos. So in order to run this test, you can click on either of these diamonds. And if you try this, we have a targeting problem because somehow when I just created this test unit, it shows a higher deployment target than the one that is in the simulator. So I'm just going to change the deployment targets to list test project. You see here I have a deployment target of 14. And in order to change this for my test target, I need to go to build settings, need to scroll down. And here you see under deployment and under iOS deployment target that we have indeed a iOS 14.2, and I'm changing this to 14. Now I can go back to my test target. So you can also run all of your tests at once by clicking on this diamond in your navigation area. And we have a green, which means that our test succeeded. If you, for example, change here the item count to 1, and you can run this one test again, you see that it failed, and it shows us that it failed at this condition. I change this back to 0, run this one again. What I now can test here is add a new item. And now what should be true is that I have here one item. So I can test xct assert true. And what should be true is now my manager's items count should be 1. Should have one to do after adding. So I run this again. And this succeeds. This is an example how you can write unit tests for your view models, because this will have the main logic to handling and manipulating your data. So I hope this little demo helped you now to understand model view and view model and what tools we have in SwiftUI, which make it really easy to implement this architecture. If you have problems organizing your code, you always, for me, it helps to think of state. So what is the state my application can be in? And from there on decide, okay, this is the data I have here, this is the information I want to show here, this is the state in this case. If you see it from the point of a UX designer who gives you the design of the application, you have the design of each of the different screens, and each of them describes a different state of a user journey. So this is already giving you a good idea of the different states and the different truths that you want to describe. From this point, you know which states are there. And then the question is it a local state that is more defined to a single screen? Or is it something more global, that a truth that affects all of your application? And from there on, you can decide if you want to put it in the environment, if you want to have a view model, if it's enough to have a state property. It definitely takes some time to get used to this declarative state-driven development. But if you see a couple of examples, and even if you are only doing this for a small project like this one, I think it already helps you, because from now on, you already have a template to go for. This was a rather short, compressed introduction to MVVM for SwiftUI. If you have any questions, leave them in the comments below. If you liked this video and you want to see more, please hit the like button and subscribe to this channel.